Hey, welcome to the second video on surds. So by the end of this lesson we should be able to express a surd in its simplest form, and we should be able to simplify surds in context. So expressing surds in their simplest form. Let's take a surd here, the square root of 8, and we can actually express this by finding the product of two integers inside this square root or underneath the square root term. So we can express this as a square root of 1 times 8, and we could also express this as a square root of 2 times 4. We can split this 2 times 4 up under the square root as the product of two square roots itself. So the square root of 2 times the square root of 4 is the same thing as the square root of 2 times 4. And I'd recommend you use a calculator just to check that this is the case, just for your own satisfaction. We can say that this is the square root of 2 times 2 because the square root of 4 is 2. We can also rearrange this as having the 2 at the front, so it would be 2 times the square root of 2. And we can actually just say that this is 2 root 2. And this here is expressing the square root of 8 in its simplest form. This is a simplified surd. Okay, so what we're going to do is we're going to try and simplify the square root of 18 this time. So the process in simplifying surds like this, we need to find the factors of 18. And the key here is that one of those numbers must be a perfect square. So let's think about the factors of 18 first of all. Well, we could have the square root of 1 times the square root of 18. We could have the square root of 2 times the square root of 9, or we could have the square root of 3 times the square root of 6. Which of these three contains a perfect square within them? It is, of course, this one, because 9 is the square of 3, so the square root of 9 would be 3. So we're going to take this one and we're going to simplify it using this. So we're going to convert this to the square root of 2 times the square root of 9. The square root of 9, as we said, was 3. And now we can actually just put the 3 at the front and call this 3 times the square root of 2 like this. So this is kind of similar to algebra, where we put the variable with a pronumeral, but in this case we've got the surd. And that is the correct answer. Have a go of simplifying the square root of 32. Okay, so we've got the square root of 2 times 16, and we got the square root of 4 times 8. So which of these contains a perfect square? Well, in this case, both these contain a perfect square, because 16 is the square of 4, and 4 is the square of 2. So actually, both of these could be used. So let's first of all take the first one, and we got the square root of 2 times 16. Let's split that up as a product of two square roots, and we know that this can be converted into a whole number. So we got the square root of 2 times 4, and we're just going to rearrange it to be 4 times the square root of 2. And that is the surd in its simplest form. Quite straightforward, but there is a little bit of a problem here, and I'm going to show you an error some people make. So let's go back to the other example we had, where we could also express this surd as the square root of 4 times 8. Now let's split that up and then continue as before, where the square root of 4 becomes 2, and you will have 2 times the square root of 8, and you might be tempted to say, there we go, 2 root 8 is a surd in its simplest form, and be done with it. However, that isn't in its simplest form, because this square root of 8 itself can be simplified even further. Because the square root of 8 could be expressed as the square root of 4 times 2, which would be 2 times the square root of 4 times the square root of 2. Square root of 4 turns into 2, so it would be 2 times 2, which would be 4 square root of 2. And we get the answer we got using the other two numbers, like that. So be careful, because you can easily lose marks if you don't follow through and simplify further. So let's simplify surds in context. A very common example of using surds in a mathematical context. We're asked to find the value of x expressed in the simplest form, and we're given a triangle, and we're given the length of two of the shorter sides, and we're trying to find the length of the hypotenuse. So we know we're going to have to use Pythagoras Theorem here, where we're trying to find x as the square root of the product, the sum of two squares. So we've got 4 squared plus 6 squared all under the square root. 4 squared is 16, 6 squared is 36. So we've got the square root of 16 plus 36, which is the square root of 52. Now we have to simplify the square root of 52 to be in its simplest form. So we can split these up in many ways, but the one with the square number in it would be the square root of 4 times 13, which simplifies to 2 times the square root of 13. And this there is the surd in its simplest form.